Hello, Aiden. This is 4-5. We're gonna only do like a couple of like the first example for tessellations. Did you guys remember doing tessellations in like Mrs. Crano's class?
No.
Okay, where you have like figures that are all like combined together and stuff? No?
Oh, like a tanagram.
Yeah, like a tanagram, whatever. Okay,
We
but
should do that for
tessellations. The only difference is that a tessellation, it's not like the same thing as a tanagram or tangram, whatever it
We
is.
should do tanagrams
Okay.
for Thanksgiving.
Like tanagram turkey.
I know, those are fun.
We should
Um,
do that.
But a tessellation is using the same object over and over again to like make like floor tiles. Does that make sense? Like you're making designs, like I think of these as like bathroom floor tiles, right? So you're trying to take the same shape and you're putting them together, okay? So this is called a tessellation. Circle that word, tessellation. We have different types of tessellations. This is one type of tessellation, okay? And what shapes are these?
Trapezoid.
Those are trapezoids, okay? And what they've done is they have taken a trapezoid that looks like this, and these are the dimensions of it. These are each 60 degrees, and these are each 120 degrees, okay? And what they've done is boys, are you listening? Shh. What they've done is they mapped it over and over and over again, and they've connected them, so they flipped them upside down and done all that stuff. And what we want to pay attention to is when we repeat this shape over and over again, and when I put 4 of them together, or however many I need to put together, will it all come together and fit? Okay? And the thing that we want to pay attention to is that all of these angles have to add up to be 360 in order to make a full circle that we have right there in that tiny vertex area where all of those shapes are coming together. Would that add up to be 360? That's what we're interested in finding out. This one does, in fact. So we are creating a tessellation. All right? Now this is a tessellation, but this is not regular sized objects, okay? So let's go down here and let's talk about a regular tessellation. Put this off to the side. In order for a figure to be regular, all the sides have to be congruent. So I'm just going to say all sides equal and all angles. I'll just say angles. Angles are equal, okay? All the sides are the same length, all the angles are the same. So in my trapezoids that I had up here, are those regular figures? The sides are not all the same, and the angles are not all the same. Some of them are 120, some of them are 60. None of them are, like, not all 4 of them are the same, okay? So a regular figure would be like, maybe like a square, right? What about a rectangle? Is that a regular object? The sides are not the same, so a rectangle does not work. Triangles. Let's say I have a triangle like this. Is that a regular figure? No. Some triangles are if they are equilateral. An equilateral triangle is a regular figure, okay? So let's bump over here. These are all equilateral triangles, right? That they fit together, okay? And so what I'm looking at is, let's talk about one triangle right here. And let's say I know that one angle of a triangle, if it's an equilateral triangle, one of the angles is going to be 60. Actually, all of them are 60s. How do I know that? In an equilateral triangle, how do I know that the angles are all 60s?
That's because they're all the same.
Yeah, 180 degrees is how much a triangle has, and then if I divide it by 3, because all of them are the same, each one is 60, right? Okay, so here's the deal. I'm looking at this one angle, and I'm going to say, like, can I put a bunch of these together to make, like, a tessellation? So I'm looking at, like, at the vertex of where these would all come together. Could it possibly make 360 degrees? The place where all of these shapes come together, could it possibly make 360? How do you know that?
Because it's
circle.
One of the angles is 60, and if I put a bunch of them together, could they possibly make 360?
How many?
As many as I want to. I don't know how many.
Yeah.
Could I fit a bunch of them together to make 360? Yeah. How do you know?
That's how that works.
360 divided by 60, because that's what one of them is, comes out evenly, right? It is 6. I would need 6 of them to go around, but they would all come together, and if I use 6 of them, I would make 360 degrees. That's how I know all of the angle measures would come together, right? Okay, let's say instead I had a triangle where I have, I don't know, like a little bit different. Let's say this is 50 degrees, okay? And this is 70, and this is 60. Let's say I have a triangle that's not an equilateral triangle, and I'm trying to match all of these guys up. So I'm putting all the 50-degree angles together. Would that tessellate? Would that work?
No.
Why not?
Because you
Because
need
it's not
7.2.
360 divided by 50, because each one of them in that corner is 50 degrees. If I divide that, you said 7.2. I would need 7.2 of these triangles to tessellate around to make that vertex. Does that make sense? It would not all fit together. So that would not tessellate. Versus the 60-degree angles, they would, because they would all make 360s. Correct? Okay? All right, so let's go down to, I'm going to skip the uniform, semi-regular, all that stuff. Let's skip down to example 1. Okay? They don't give you very much background information before you do example 1. So I'm going to give you some stuff up here. Write this down. Here we have a triangle. How many degrees are in a triangle that has 3 sides? 180 degrees. Do we know that? Commit that to memory. 180 degrees inside of a triangle. So that means all of the angles. If I add these all together, that would be 180 degrees. Yeah? Okay, now I'm going to bump over to a 4-sided figure. It doesn't have to be a square. It could be a rectangle. It could be a parallelogram, whatever. If it has 4 sides, how many degrees are all of them adding up to be? 360, okay? Now, if I have a 5-sided figure, 1, 2, 3, 4, 5, that's a pentagon. 5 sides. How many degrees do all of these add up to be?
Is it gonna be like 360?
360.
360 plus 180.
360 plus 180. That's looking like the trend right now, right? Like you're adding 180 every time?
360
Okay.
plus 180.
What's 360 plus 180?
540.
540, okay? Now let's say I have a 6-sided figure. 1, 2, 3, 4, 5, 6. 720, okay? That's a 6-sided figure, okay? What happens if I have a 16-sided figure?
I'll figure that
900.
one out. Genius.
Wait. Hold on.
Wait, let's come up with a pattern here, right? If I have a 16-sided figure, I don't have to figure all of them out from 0 to 16, right? A 3-sided figure is 180 degrees.
14.
A 4-sided figure is 360. A 5-sided figure is 540. A 6-sided figure is 720. Here's the rule.
Oh, wait.
So I don't have to like figure them all out up to 16. Are you ready for this? We know the only thing that you have to remember is that a triangle is 180, right? Okay, you ready for this? If I take a quadrilateral, this guy right here, and I do one of these, I have a triangle here and a triangle here, which means I have 2 triangles, and if I take 2 times 180, I get 360. Okay, now if I have a pentagon, I'm going to just create some triangles there. How many triangles do you have?
3.
3 triangles. 3 times 180 gives you 540. If I have a 6-sided figure, I'm going to have how many triangles? 4 triangles. Times 180, 4 times 180 is 720, okay? If you have a 16-sided figure, how many triangles will you have?
A lot. 15?
14.
Let's look at the trend. A 3-sided figure has 1 triangle. A 4-sided figure has 2 triangles.
14.
5 becomes 3. 6 becomes 4. What's the trend?
14.
Oh, minus 2.
N minus 2. Put that somewhere. N minus 2. That's the number of triangles that you have. Okay, so if it's 16-sided figure, it would be 14 triangles. You take that times 180. What's 14 times 180? Like a real big number.
I got it.
I'll send this to you. You'll only have to watch like the last like 3 minutes of it. What?
2,520.
2520. Perfect. Okay, so going down to this example down here. It says determine whether, listen to this, determine whether a 16 gone, that means like a stop sign but double the amount of sides, right? A 16-sided figure will tessellate. We're trying to decide if it will tessellate. That means like will all of the sides stick together. So a 16-sided figure, blah, 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 like all the way around, I don't know, okay? All of these angles are going to add up to be how much? What will all of those angles of a 16-sided figure add up to be?
The one we just.
Whatever we just did, 2520, right?
Yeah.
All of those angles will add up to be 2520. Yeah? Okay? Because we did n minus 2, which is 14, and we took 14 times 180, right? Now, how do I figure out what one of these guys is?
You
Divide.
divide.
Divide by 16 or 14?
Oh.
14. 16.
16. We're going to divide it by 16. So 14 triangles, but we're dividing by 16 because there's 16 angles. What is 2520 divided by 16?
157.5.
157.5. Each one of these angles is 157.5, 157.5, 157.5, all the way around, right? So let's pick on this angle. Let's say he's a vertex right here. Okay? And I have another shape here and another shape here and another shape here, whatever. Will those tessellate?
Yes.
No.
No.
I want this intersection where all of them intersect, I want it to add up to be 360. Can they add up to be 360 if one of the angles is 157.5? If I have another one, 157.5, and another 157.5, I don't know how many I need, but will it eventually add up to be a perfect 360? If you take 360 and divide by 157.5, will it come out evenly? I think you need like 2.5 or something.
Yeah.
2 point,
Oh, I just deleted it.
2.5, whatever. Okay, so you would need a half of a shape, and that's not going to work. So that will not tessellate. Determine whether it will tessellate the plane. No, it will not.
It's just the stone.
Because 360 does not divide 157.5 evenly, yeah? Okay? Let's go ahead and do number 3 really quick together.
I'm good.
On your homework assignment, you have to do 1, 2, and 3. First of all, on number 1, a pentagon has how many sides?
5.
5. A hexagon has how many sides?
6,
6. A nine-agon has
8.
9-sided figure, right? Remington. Okay? So we're trying to figure out, will this 9-sided figure tessellate the plane? Blah, 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 all the way around, right?
Good man.
Okay? So I need to figure out what each one of these angles is in order to figure out whether it will tessellate the plane. The first thing that I have to do is figure out how many degrees are inside of here. What's the rule?
7 triangles.
How many triangles are there?
7.
N minus 2 is 7, right? 7 times
180.
180. What's 7 times 180? Like 50, 40, I don't know what it is. Is it 50, 40?
No.
No, what is it?
1,260.
1260, okay? 1260, okay? So what is each one of them?
So divide by 9.
So divide by 9, because there's 9 total. 140, okay? Each one of these guys is 140, okay? If I lump them all together like a soccer ball, and I'm putting one shape here and one shape here and one shape here, whatever, will those all add up to be 360? Will he tessellate?
No.
360 divided by 140, does that come out nicely?
No.
No.
No? How many is it?
2.6.
2.6. So I would need 2.6 of those to create a full circle at that joint. Does that make sense? So, no, he will not tessellate the plane. Make sense?
Yeah, that makes sense.
Yeah. Like this is how you figure out, do the shapes even fit together? No, they will not fit together. Make sense?
Mhm.
Yeah. Okay, so do the same thing for a 6-sided figure and a 5-sided figure, and that's it. Okay? Great, that's all I have. We'll do the rest tomorrow.
Can't do anything.
Goodbye.